Hi everyone, welcome to Moscan. So in today's video, we have been given one common source amplifier whose gate is connected to input voltage Vi, and in this question we have to find out the minimum and maximum value of this input which this amplifier can support and can work as intended. So let's start solving this question. So first of all, since this is a common source amplifier, we know the small signal gain AV for this amplifier can be given by V0 upon Vi, and that would be equal to minus of GM1 into RDS, which is given to us in this question. So we easily have figured out the small signal gain for this amplifier. This will be used going forward, so that's why we already have written here. Now, in order to calculate the minimum and maximum input value which this amplifier can support, let's start to calculate first the gate potential which this amplifier will have. So gate potential is denoted by Vg. If I have to write the value of this gate potential, that should be equal to applied input voltage plus quiescent voltage at this node because of gate potential. Now, if you see here, gate and drain are sorted. There won't be any current flowing from drain to gate because of the high input impedance of the gate. So we can assume gate and drain are sorted. So first of all, let's try to calculate the value of quiescent potential at drain. Now if you carefully observe this circuit, this is biased by one DC current source I0. This amplifier will work as in saturation region. So ID current, we know equation for that, half mu n Cox W by L VGS minus Vt whole square. This is the equation which we follow. So from here, if we try to calculate VdQ, which is actually equal to VGS or VGQ, so we can write here this value of this quiescent potential at drain will be equal to Vt plus root 2Id upon mu n Cox W by L. This would be the value of quiescent potential at drain. Now if we need to write value of drain potential only, so that would be the summation of quiescent potential plus output potential. Output potential value we know from here that would be equal to minus GM1 RDS into Vi. So we can write that this would be equal to, just now we calculated Vt plus root 2Id upon mu n Cox W by L minus GM1 RDS into V input. This would be the value of drain potential. Now, if I have to write the gate potential, that would be equal to V input plus VGQ, that means quiescent potential at gate, which is ultimately equal to quiescent potential at drain. So this value we can put here, that is equal to Vt plus root 2Id upon mu n Cox W by L. Now we know the value of gate potential, we know the drain potential value. So let's try to understand the minimum and maximum value of input which this amplifier can support. Let's talk about the maximum one first. If I have to figure out what would be the maximum input potential, so we know if this amplifier has to work, this will work in saturation mode, and there we will see the maximum current, right? So what is the condition for saturation? The condition for saturation is Vd should be greater than Vg minus Vt. And we know the values here. So if I replace Vd value from here and Vg value from here, you will see Vt plus 2Id, these terms will get cancelled out. So ultimately what I will get minus GM1 RDS into V input should be greater than V input minus Vt. If I bring V input on the left hand side, so negative V input, and I will ultimately get 1 plus GM1 into RDS should be greater than minus Vt. Minus minus we can cancel out. So the maximum value of Vi max would be equal to Vt divided by 1 plus Gm1 into RDS. This is the maximum input value which this amplifier can support if it has to work as intended. Now let's talk about the minimum one as well. So if this amplifier has to work, if we have to find out the minimum value of input, that means the current will become zero, right? So what will be the value of current that we need to equate to zero and we'll get the minimum value of input. So the current value will be equal to I naught, which we are forcing from top, along with that MOSFET small signal current, which would be equal to Gm into VGS. VGS value is nothing but V input, right? This should be equal to 0 if we have to calculate minimum value of Vi. So from here we can calculate Gm1 into Vi would be equal to minus I naught, and Vi minimum would be equal to minus I naught upon Gm1. So this is the value of minimum and maximum input which this amplifier can support. So overall, if you see, this was an easy question, just we need to apply the saturation current equation. But how we are dealing with the net potential, how we are calculating drain and gate potential, that was an important learning this question. I hope you got to learn something new from this video. If you found this video useful, please share with your friends. And if you haven't subscribed to our channel, please do subscribe.